Hey there everybody, we're going to be going over 9.5 exact values and how to calculate them out. So when we start taking a look at slide 2, the first thing to understand is that all we're doing here is translating exactly what we were looking at before as far as our trig functions and relating them to a circle. So in this case, what we're going to do is that as we look to the very common triangle that we are used to, ultimately what we are doing is turning this into a circle. And what we are doing is making everything connect. So once where we were looking at opposite, hypotenuse, adjacent for SOHCAHTOA, now we are looking over at our x, our y, and our radius. And that's exactly what we have here within this equation. So in order to find the radius or the hypotenuse, we would have to use the equation r is equal to the square root of x squared plus y squared before we would be using the Pythagorean theorem. So here on this slide, we go over the different equations that you would have for a sine, cosine, tangent, and their inverses. In slide 3, we're going to start taking a look at some of the other trig functions that we have to keep in mind when working with any of these problems. The first thing to keep in mind is that our cosine of theta is equal to x, and our sine of theta is equal to y. So every time that we take a look at a point, x and y, we are really looking at cosine and sine. Something else to keep in mind is that tangent of theta is equal to sine over cosine. Our cotangent, remember, is the inverse of tangent, which means instead of sine over cosine, we're going to have cosine over sine. Secant and cosecant, keep in mind, are the inverses of cosine and sine. So in this scenario, when we are looking at secant, we would say 1 over cosine, and cosecant of theta would be equal to the 1 over sine theta. We first begin with the signs of a trig function. So here, all we are doing is that we are beginning with understanding what is within every quadrant. We know that all students take calculus. And the next thing that we have to understand is what exactly the problem is asking for. The problem is asking if sine theta is less than 0 and cosine theta is greater than 0. Name the quadrant in which the angle lies. First thing is understanding where sine theta is less than 0. First, we understand that this would be negative, because if it's less than 0, it would be negative. Next, we have to talk about our cosine. It's saying that cosine of theta would have to be greater than 0, which means cosine theta would have to be positive. When we take a look at cosine theta can only be positive in one of two locations. Cosine theta can only be positive in quadrant 1 and quadrant 4. Now, we have to take a look to see where sine is less than 0, or where sine is negative. In this case, we're going to take a look. Notice in quadrant 1, sine is positive, so it can't be that. In quadrant 2, sine is also positive. The only possibility where we could have sine be negative while also having cosine be positive would have to be in quadrant 4. Now, you may ask, but the real question is, why can't it be 3? Keep in mind, even though, yes, sine is negative in quadrant 3, cosine is not positive in quadrant 3, which is the main reason why our answer is quadrant 4. We're going to repeat the same process for our second question. Draw out our table, all students. Take calculus. It says sine of theta is greater than 0, which means this would be positive. And cosine of theta is less than 0, which means negative. We're going to first take a look at where is sine positive, and that would be in quadrant 1 and 2. Cosine is negative in quadrants 2 and 3. The only place where those two quadrants overlap would be quadrant 2. Now we're going to go ahead to slide 5. The same scenario is happening here. Now the only real difference is that an actual value is being given, and they're telling us the trig functions that go along with them. So we're going to first begin by figuring out what it is that we're looking for within this slide. It says find the value of each of the 4 remaining trig functions of theta. So we're going to go ahead. We're going to start off with sine is already given. So we're going to go with cosecant. We're going to look for cosine being given to us, which means secant. We need to still search for tan and cotangent. Keep in mind, this is all of theta. Now, when we say cosecant, remember, this is the same as 1 over sine, which is the inverse of what the sine is already given, which is 10 over the square root of 10. And secant can be determined because it's the inverse of cosine, which was already given at 10 over 3 square root of 10. Now the question is really, how do we figure out our tangent and our cotangent? Well, we first have to understand what is being given to us. Sine was initially given to us, sine of theta, and notice sine of theta was positive. A positive square root of 10 over 10. And cosine was also a positive 3 square root of 10 over 10. Now, in order to find a location where all are positive between our sine and cosine, the only possibility would be within the first quadrant underneath the A. So, first thing we're going to do is draw out our first quadrant. Now, this would go ahead and stretch into the first quadrant and drop down. We know theta is going to be in this corner right here. We know that sine of theta is square root of 10 over 10. So our opposite is square root of 10. and our hypotenuse, or our radius, is going to be 10. We're still given a piece of information, which is our cosine. Keep in mind, we don't have to use our Pythagorean theorem or our other equation as long as cosine goes ahead and fills up that last spot. Remember, cosine is adjacent over hypotenuse. Well, we have the hypotenuse already at 10, but the adjacent is 3 square root of 10. Knowing that, we're then able to solve for tangent. Tangent is opposite over adjacent, which is the square root of 10 over 3 square root of 10. Now, cotangent is extremely simple to solve because we can go ahead and get the inverse of it. Before we go on to cotangent, let's simplify that a little bit. Square root of 10 divided by 3 square root of 10. The square root of 10s cancel out. And in this case, we are ending up with 1 over 3. Now keep in mind, the cotangent is the inverse of tangent. So instead of sine over cosine, we are actually looking at cosine over sine, or the inverse of tangent, which would be giving us an answer of 3. Let's go ahead and take a look at slide 6. Here we're going to work on the exact same problem. What I would suggest, go ahead and work this one on your own. Pause the video for a quick second while you work on it and double check in 1 second. So we're continuing on with slide 6. Slide 6, we take a look at first what is going on with what's being given. In this case, sine and cosine, they are both positive for this case. So we know that we're going to be working with quadrant 1. Our 90-degree angle would be here, and theta would be there. Once again, we're going to work with the inverse of sine, which is cosecant of theta, secant of theta, tangent of theta, and cotangent of theta. Whenever finding cosecant, keep in mind we are going to go ahead and do the inverse of sine. So this would be 10 over the square root of 47. Keep in mind, sine would be opposite over hypotenuse. Our opposite would be the square root of 47. And our hypotenuse would be 10. Our cosine, notice, is the square root of 53 over 10. Our adjacent would be the square root of 53 over 10. Secant would be the inverse of that, which would be 10 over the square root of 53. Tangent is sine over cosine. Now, when we divide this out, sine divided by cosine will actually end up being the square root of 47 over 10 times 10 over the square root of 53. Notice our 10s cancel out, and we're going to end up with the square root of 47 over the square root of 53. Our cotangent, remember, is the inverse of tangent, which means cosine over sine, which is the same as the square root of 53 over the square root of 47. Let's take a look at slide 7. Now, in this slide, what's occurring is that you are being given a specific point. That point is 4, -3. So we have to understand that even though a point of 4, -3 is being given, this is also describing our x and y, or our sine and cosine. So what happens? When we take a look at 4, -3, 4 is our cosine, and -3 is our sine. Now, as we look, the only location where this point could be would be in the 4th quadrant. Four would be our x, -3 would be our y. We need to go ahead and find our hypotenuse or our radius, because remember, we're working with a circle. This is where we use the equation of r is equal to the square root of a squared plus b squared, or x squared plus y squared. So 4 squared plus -3 squared. We end up with 16 plus 9, which gives us the square root of 25, which gives us our radius being 5. Now that we have all 3 of our sides, we would then be able to solve for all 6 trig functions that we have. Notice if you take a look at the slide above, you can easily spot how all 6 trig functions were calculated out. Keep in mind, the main items that were used were SOHCAHTOA when finding the appropriate values for each one of these trig values. In slide 8, slide 8 is extremely similar to what we've been doing, but it tends to blend together the two methods, for cosine theta being -8 over 17, and cosecant theta being less than 0. So let's go ahead and work A together. In this case, cosine theta is equal to -8 over 17. -8 over 17. Keep in mind, since we're working with cosine, our cosine is the adjacent over hypotenuse. So we first have to figure out what quadrant are we even looking at. Notice cosine is negative, but cosecant is also negative. We go ahead, we lay out our quadrants. And we quickly realize that in order for cosine to be negative, it would have to be 2nd or 3rd quadrant. Cosecant being negative would have to be 3rd or 4th. So we would be looking at the 3rd quadrant. Now we know that theta will be in this corner over here. 90-degree angle would be in this corner. Now the adjacent is -8. And 17 is our hypotenuse. We need to go ahead and find our y. Now in this case, in order for us to do that, we're going to go ahead and plug in our value into our remaining equation. Remember, radius is equal to the square root of x squared plus y squared. Now our radius, remember, is 17. First thing that we're going to do is we're going to go ahead and square both sides. So 17 squared would give us 289. And that's going to leave us with -8 squared, which is 64 plus y squared. Our next step is to subtract 64 from both sides, and we end up with 225 is equal to y squared. We're going to get the square root of both sides. Y is equal to 15. Now keep in mind, since we're getting the square root of both sides, it's going to be a positive or negative 15. Most importantly, this would be a negative 15. And we know that because we're in the third quadrant and we are going to drop down, which means that negative 15. Now that we know that we have negative 15 for that final side, we can go ahead and plug in whatever else that we may need to do. Now this could be finding all of the trig functions. It could be just constructing a reference triangle. It truly depends on the question, but this would prepare you for all of them. Notice in this question, all we're being asked to do is just construct the reference triangle. So slide 9 is the same as our B example here. So we're going to go over to slide 9. So in this slide, notice we have tangent of theta is equal to -1/2. And we have cosine of theta being greater than 0. First thing is, cosine is positive at quadrants 1 and 4. Just in case we draw it out, all students take calculus. Tangent equaling -1/2 would be either quadrant 1 actually. Sorry about that, guys. Tangent of theta. Now keep in mind, tangent of theta is sine over cosine. Now, in this case, what would occur is, since sine is negative, only place where sine can be negative would actually be quadrants 3 and 4. Cosine would be positive, which is 1 or 4. In this case, we are looking at quadrant 4. Notice theta would be over here in this corner, 90-degree angle. And we're first going to start with putting down what we know, which is, in this case, a -1 for the y, a 2 for the x. Keep in mind, remember, x and y is the same as cosine and sine. We need to go ahead and solve for our radius. Remember, radius is equal to the square root of 2 squared plus -1 squared. So radius is equal to square root of 4 plus 1. Our radius is the square root of 5. In our final slide, we're going to take a look at, find the quadrant for the terminal side of theta, and find the 6 trigonometric values if cosine is equal to 2/5 and sine of theta is less than 0. So the first thing that we're going to do is we're going to go ahead and label everything that we have. Off in the corner, we know that all students take calculus. We can easily spot that our cosine is positive, our sine is negative. Keep in mind, cosine being positive would only occur in 1 and 4. And sine being negative would only occur in 3 and 4. In this case, this is all going to occur within the 4th quadrant. We know that cosine of theta is equal to 2/5. So our adjacent is 2. Our hypotenuse is 5. And we're going to go ahead and solve for that remaining side. In order to do this, we would do 5 is equal to the square root of 2 squared plus y squared. We're going to square both sides and get 25 is equal to 4 plus y squared. 21 is equal to y squared. And y is equal to the square root of 21. Now keep in mind, this is positive or negative. We know it's going to be negative because we are in the 4th quadrant. So this would be a negative square root of 21. We're going to go ahead and solve our trig functions. We're going to start off with cosecant of theta being, now keep in mind, this is 1 over sine. So we'll go ahead and start with sine in the first place. So let's go ahead and start with sine. make our life a little bit easier. Sine is opposite negative square root of 21 over hypotenuse, which is 5. This means cosecant of theta is equal to a negative 5 over square root of 21. We're going to go with cosine, which we already know is 2/5, which means secant is 5 over 2. And our last remaining pair would be cotangent and tangent. Tangent is equal to sine over cosine. Keep in mind, sine is negative square root of 21 over 5. And we're going to multiply that by the inverse of cosine, which is 5 over 2. Our final answer here would be negative square root of 21 over 2. Remember, 5's slip away because they're getting canceled away. Last would be our cotangent, which is cosine over sine, which is negative 2 over the square root of 21. Now notice we're just providing exact values. We are not going to go ahead. We are going to keep this just as is. We're not going to go ahead, rationalize it, but in the case you did, remember, if you were rationalizing, you would have to get rid of any square roots that you had in the bottom by multiplying the top and the bottom by that square root. Notice, keep in mind, here we are not doing the rationalization of our denominators. If you have any questions or anything along those lines, please feel free to send me a reminder or an email.